Bismillahirrahmanirrahim. Now we will learn how to model this crashing in linear programming. So for linear programming, we need to define the decision variables. We will define two types of decision variables. One is the how much we can crash, and another is for defining the network. We need to define another decision variable. So let's say yi is the number of weeks to crash, or weeks activity I is crashed. All right, and we define xi is the, for defining the network, we define another variable xi, and we say xi is equal to earliest finish of activity I. Okay, where I is equal to, in this case we have A, B and up to H, all these activities. Now we can start with the activity by crashing those constraints. Crashing constraints, we can write down that, it's easy. So we say ya is equal to less or equal to 1, 2 minus 1 is 1, yb less or equal to 2, yc less or equal to 1, 2 minus 1, 1, and yd less or equal to 1. Similarly, we can put ye is less or equal to 2, yf less or equal to 1, and yg less or equal to 3, and yh less or equal to 1. We could have written the objective function also. Let's say objective function z is equal to, minimize, z equal to, and we have the crash cost. So we have 1000 ya, number of weeks crashed, plus 2000, or we can put I put 800 there, we can put 800, it doesn't matter. I just show how to model 2000 yb plus 1000 yc and plus, how much is activity D is 1000 again, 1000 yd plus E is 1000 again, 1000 ye plus 500 yf plus 2000 yg plus 3000 yh. Remember that we have to put all the activities in the objective function, not only the critical path activities, because while we are crashing the project, we will see that a new path emerges. So all the activities should be put in the all the activities that can be crashed should be put in the objective function. We need to define, now we have already defined the variable, sorry, we need to put the constraints for the network now. For network, we have defined xi. Xi is the earliest finish of activity I. First of all, we can also write down that x start, let's say, is 0 time. Okay, and let's say x finish is, let's suppose that we want to complete this project in 12 or less than 12 weeks, so we put less or equal to 12. Okay, now we define the network. We have x a, we have said xi is earliest finish of activity I, so xa is the earliest finish of activity A. Earliest finish of activity A will be greater or equal to x start all right, plus the normal time it takes, which is 2, minus any crashing we do, minus ya. Okay, it's easy to write these inequalities. Similarly, we can write xb is greater or equal to x start plus the normal time of activity B is 3 minus any crashing of B. Okay, let's look at activity C. Activity C is the earliest finish of activity C is greater or equal to earliest finish of activity A, which is xa, okay, plus the normal time it takes, which is 2, minus the any crashing of activity C we do. Let's do for for D, earliest finish of activity D then will be greater or equal to earliest finish of activity B plus the normal time of activity D, which is 4, minus any crashing we do of activity D. Now, since we have to give this in what we call it, in, let's say, in Excel or any other program, the right hand side should be some numerical value. So what we will do, we'll just put this in an order form. So we will write this inequality in order form, and then I will just quickly write the others because it will become easier to write those constraints. So here we write down ya plus xa minus x start is greater or equal to 2, and similarly yb plus xb minus x start is greater or equal to 3. And then we can write down the others as well, yc plus xc minus xa greater or equal to 2, and yd plus xd minus xb greater or equal to 4. And now we will just keep going like that. We can write down the others like ye. Ye will be ye plus x, which is coming from c, so xc minus xe first, xc coming from xc, so xc greater or equal to the normal time of activity completing this activity. Let's see, yf will be yf plus xf minus coming from c, so xc greater or equal to normal time of activity f. And then we write down for g. Now remember that g has two two what we call it predecessors. So we will have two inequalities, yg plus xg minus coming from exe greater or equal to 5, and we will have yg plus xg coming from d. All right, so minus xd greater or equal to 5. And then we have left with only h. H will have also two inequalities. One is one is coming from f and one is coming from g. So we will write down yh plus xh minus coming from f greater or equal to normal time is 2 for this activity, and yh plus xh minus coming from activity g greater or equal to 2. We need to have one more constraint, which is that the finish of activity x finish x finish is greater or equal to xh, the last activity. This is a complete formulation. We have defined the variables, and we have formulated the objective function, and then we have all these constraints. Of course, the non-negativity constraints we can write down that all xi's are greater or equal to 0 and all yi's are greater or equal to 0. This is the complete formulation of this problem to crash the project using linear programming. Okay, now I will show you how to crash the project using Excel linear programming here. So we have formulated. This is all explained in the book. I will not explain it to you. I have already put this file in your in Moodle. You can see that this is the objective function is on the top here. This is the objective function. Okay, and then of course we are crashing up to 12th week, and here is the crashing cost here coming here, $5,000. And of course these are the constraints mentioned earlier. The first constraints are these constraints are related to the crashing, and these are related to the network. Okay, that's it. I mean, this is you can check it out. I have done it in a neat way. This is I would say a better way of doing it. I don't know. What I have done is I just have these variables xi and yi's, which is the earliest finish of activities here. These are the variables, and these are the another variables, yi variables of amount of crash. Okay, we will not fill these, and this will be calculated by solver. This is the crash cost per week, and on this this column, F column, is allowable crash time. And here I have written symbolic network constraints, so that the constraints are given here in column H. We are giving the constraints, actual constraints. I can show you here, for example. Let's look at this one, and it's saying this is the same as what it symbolic network constraints. I've just done ya plus xa minus x start. So here it is ya plus xa d5 plus c5 minus c13 is x start, and that's the actual equation is given over here, or actual constraint, let's say. And this is the right hand side. All right, and that's it. I mean, it's very neatly done here. All the constraints are first written in symbolic network constraints are written, and then the network constraints actually, which will be given to the solver. And then we can go to the solver. Where is solver here? We go to data and go to the solver, and already we have defined the objective function is over here, C16, cell C16. It is a minimization problem, changing variable cells. These cells xi and yi's are going to be column C and column D are the variable cells here, and subject to the constraints. The constraints, if I may close it, what are the constraints? We have two constraints, two types of constraints. We have that the left hand side is less than or equal to greater or equal to 2. All right, I mean this side, this one are greater or equal to this one. Okay, this all, and this is one constraint, and the second constraints are that the allowable variable amount of crash should be greater or equal to, see over here, for example, we go to home, and it is it's the where we have put this, the formula, this should be greater or equal to this one. This is put in the solver. I go back to the solver, data, solver. So these are the two constraints here, and we have just make unconstrained variables non-negative and choose simplex, and then close, or you say solve, and you get the solution. You say okay, and we have the solution over here, and this I have given also the solution over here. So this is I thought that this is a neater way than doing with the book style. You can look at this one if you want. If you are comfortable with this way, you can do it with this way. If you are comfortable with this one, you can use this one. I have put this Excel sheet also in Moodle for you to check it out, and also I have given a case study, so you will be doing this for your case study. You will be using linear programming to crash the project. Some other topics in project management. If the project is large, we can make sub-projects. For extremely large projects, an activity may be made of several smaller sub-activities, which can be viewed as a smaller project or sub-project of the original, or modules we can make them, and then according to those modules we can modules can be considered as activities, and then we can do PERT CPM on them. Another thing is milestones. Major events in a project are often referred to as milestones and may be reflected in Gantt charts and PERT charts to highlight the importance of reaching these events. If anything, for example, construction of something like power plant is there, if we have completed, for example, the foundations, that is a kind of a milestone is achieved. If we have completed some installation of equipment, that is a milestone, etc. So the milestones can be considered as the important events where we have completed a certain jobs in the project. Resource leveling. Yeah, this is a topic which we have not touched it. Resource leveling is actually we try to balance the resources. We have seen, for example, if I go back to our network again. Yeah, we in the resource leveling we have not considered these constraints, but the actual constraints could be there. For example, we are saying that activity A and activity can start in parallel. What if activity A requires a crane and activity B also requires a crane, and we have only one crane? Or we have certain equipment which is needed in activity A and also it is needed in activity B. In that case, these two activities, we are saying that they can run in parallel, but it's not maybe possible because of resource constraints. Also, resource leveling is another thing is that we try to level the resources. Leveling the resources mean that at sometimes many activities are running in parallel and sometimes only few activities are carried out, and in that case the labor is not properly used. So if we have this resource constraints there, that we want to keep a balanced labor used, then of course this kind of things we have not considered in PERT, and we have not considered these things. And these are some advanced topics of resource leveling, and you can think about it also if you are going to do it, let's say your master's project, or you have to do some PhD in that area. You can consider these things as well in your actual project. Also, many organizations, they do parallel projects, several projects, and in that case the resources are also needed and there are bottlenecks there, and that's why some of the projects get delayed because of the resource constraints. This topic is not discussed, of course, but I have given you the idea that resource leveling is a real constraint which we have not considered in our discussions. So resource leveling is the adjusting the activity start away from early start so that resource utilization is more evenly distributed over time. That is that you try to level the resources, use of resources. If there are activities which can be delayed, for example, without delaying the projects, non-critical activities, we can use them. You can adjust their starting of those activities and completing those activities, and so that the resources are levelized. Softwares, there are many project management software packages on the market for both personal computers and large mainframe machines are there. One of the well-known professional software is Primavera, for example. Microsoft can also do resource leveling, and of course Primavera can do this. Most of these create PERT charts and Gantt charts and can be used to develop budget schedules, adjust future start times, and level resource utilizations. That's it for this project management chapter. Thank you very much.